Hi everyone, welcome to lesson number 4 of our grade 9 science physics section, static electricity. Today we're going to talk about charging by induction. Induction is really cool. This is what allows you to rub rubber balloons on your hair and stick them to a wall during a birthday party. So in order to take a look and see how we charge by induction, we're going to need to use a foil leaf electroscope. So a foil leaf electroscope is a piece of equipment we use to detect static electricity, and it's made of conductors and insulators, and we should probably review what conductors and insulators are. So a conductor is a material that allows electrons to move easily through it, so a metal. And in a foil leaf electroscope, the top ball, the center wire, and the foil leaves are all conductors. And so we can show those, and these will be obvious with what I show you. There are two insulators in a foil leaf electroscope, and those insulators are the rubber stopper and the glass flask that we're going to use. And an insulator, as you remember, is a material that does not allow electrons to move through it. So the insulator keeps electrons from escaping the system is really what's going on there. So I'm going to show you a video now, and I'm going to demonstrate for you charging by induction with a foil leaf electroscope, and then we're going to explain what's going on. So this is a foil leaf electroscope, and you can see that we have a metal sphere at the top and a metal paperclip that has been bent and straightened at the bottom, and then there's a little hook on which we have hung the foil leaves. I'm going to once again use our handy dandy purple balloon that I'm going to charge negatively through friction by rubbing it on my hair, and I'm going to bring it close to the foil leaf electroscope to show you charging by induction. So when I bring it close, you can see the leaves at the bottom of the electroscope suddenly repel each other. And when I bring, provided they don't stick to the glass, when I bring the balloon away, the charge on the leaves disappears and they fall back together. If I bring the balloon close, the leaves will open up like that, and when I bring them away, they fall back together. Open up, don't stick on the glass. So a charge is being induced. Okay, so what happened there? Well, we had the charged balloon, and as you remember from yesterday, the charge on the balloon was negative. So we can take a look here. And before we bring it too close, we have a very negative charge on the balloon, as we had yesterday when we were talking about charging by contact. And around the electroscope, before we brought the two of them together, we had electrons everywhere. Electrons were throughout the system, as were protons, and we can throw the protons on there. They should be balanced, of course. I'm not going to necessarily do that. But we have protons and electrons evenly distributed through everything. Now, when we brought that balloon close, so during the interaction, I'll show the balloon quite close, but not touching this foil leaf electroscope. We have all these negative charges that are very much repelling the electrons that are around the top. So what we end up with is the protons, which we know cannot move, staying where they are, but the electrons are repelled. So the electrons are repelled from this similar charge, and they scurry on down this conductor and reside in these foil leaves. And as they reside in those foil leaves, they swing up. And we saw during that interaction that the foil leaves were both negatively charged, and therefore they repelled each other. But when we removed that balloon, the foil leaves could, the electrons on the foil leaves could go back up and evenly disperse themselves within the electroscope, and the foil leaves collapsed back down. So that's an induced charge. The induced charge is this negative charge on these foil leaves down here, because the electrons have run away from this massive negative charge on this balloon at the top.